Okay, so my screen is visible. Okay, so I will briefly talk about data warehousing. Why data warehousing, what is data warehousing, and why are companies so deeply interested in data warehousing. So before I go there, let me show you what is known as a Gartner report, which talks about what is known as what the data warehousing market looks like. Okay, so let's go there. So this is what is known as the market overview for the data warehousing space, and in the data warehousing space we are only talking about data integration tool market, which is basically the ETL tools, and like data stage, Informatica, SQL Server, SSIS, SSRS, and all those kind of things. So right now the data integration tool market is roughly 2.2 billion, and by 2011-2018 it is expected to be 3.6 billion. So the reason that I'm talking about this is primarily to show you is that the market for data warehousing and data integration is a very large market, which offers what is known as good employment for a lot of folks. And data warehousing and data integration is mainly done by large companies with good budgets, which also provides a measure of job stability and growth. uh, so let me take you to another what is known as a graph, or rather a slide. uh, yeah, is this slide visible?
No, Sujit, I can see you. It's still showing the first slide, which has your name.
Right.
Okay, I
Yeah.
think one second. Is it visible? Just let me know if it becomes visible.
Yeah, I see.
Yes, it's visible.
Okay. So so I'll start with this. So let me just repeat what I just did, in the interest of what is known as not missing out on. Okay, so I was talking about market overview a couple of seconds back, right? And a lot of people ask me this question: why data warehousing as a career choice? Does it make sense to be in data warehousing? So this market overview that we are talking about here basically talks about the size of the data integration market. So when I say data integration market, it doesn't include what is known as things like reporting and all that. It is basically tools like Informatica, data stage, that is the data integration market. And the expected growth in by 2011 to 2018 is expected to be 3.6 billion. So the point that I'm trying to make is that data warehousing as a field for career growth is what is known as an excellent career choice. And what it does basically is that it can, for those who wish to grow technically, it not only offers an entry level position, but it also offers you an opportunity to grow in the technical space. Like you could go from an Informatica developer, data warehousing developer, to a Informatica architect, ETL architect. Then you could become a data modeler, master data management, Informatica architect. So there is space, technical space, in this line, for an individual or for a developer to grow. And so for that reason, from a job perspective, in data warehousing and Informatica is a quite a lucrative field. um, any questions at this point? Okay, so what I will do now is that I will take you to the slide that I just showed you a second back. uh, so continuing with the question of why data warehousing and why Informatica, and from a job perspective, and knowing all this stuff, what I'm showing you on your screen right now is the magic quadrant for data integration tools. And to begin with, this report has been published by Gartner, and Gartner is the leading is the leading company that talks about, who's doing how well or how badly in a given area. And what we're looking at right now is the magic quadrant for data integration tools. And as you can see here, very clearly, Informatica is leading the pack. Okay, so Informatica as a company is leading the pack, and the primary tool that Informatica employs, the primary tool that Informatica employs, as part of its data integration setup is the Informatica Power Center, okay, which is its flagship tool and which is responsible for, 90% of its revenue. So the course that I am going to conduct, is primarily going to be in and around Informatica. And Informatica also has, additional tools. Informatica also has additional tools like Informatica Data Quality, which enhance the Informatica Power Center. And it also has Informatica Big Data, which is also, an addition to Informatica Power Center. And also Informatica of late has started, growing greatly in the what is known as the master data management space, which is the process which large companies use to integrate data across different sources. So before I'll just give you a small in order to help you understand what master data management is, I will just take a small case, an example, and just explain it to you. So if you look at a company like Verizon, which has landlines and, wireless lines and, TV and Fios and all these things, they have customers across different segments. And what master data management is basically at a very, very basic level is getting a single view of the customer, so that, when that individual goes into his FIO system and makes an update, in Verizon is able to understand that, this is the same customer, who is present across all the systems. So they want a single view of that, what is known as of that customer. And master data management is all about creating a single view of the customer, irrespective of, which line of business, they are subscribing services from. So, this is the overview of the magic quadrant for, data integration tools. As you can also see, there are other competitors, who are trying to, catch up with Informatica, but by far they are the leaders with the maximum number of data integration installs and the highest number of, jobs in the market as compared to any other. And it's also the easiest tool to learn and use. Any questions at this point? Vishwa, Vinoda?
I'm good, Sujit.
Okay. So what we will do now is that we will go to the PPT which covers the, data warehousing concepts. And so any questions about Informatica and data warehousing as a career choice? Okay. So what we will do now is that we will actually go and what is known as go through the data warehousing PPT. So before I go through the data warehousing PPT, can somebody Vishwa, what do you understand by data warehousing? Can you, tell me? Let's make this little interactive. Yeah.
Sure. So just from basic level,
Yeah.
so I'm just taking an example.
Yeah.
Any company having multiple line of businesses or any application, they would want to have their data to be moved across different databases. So during this process, they have set up multiple the data mart, historical, or a transactional operational database. So the movement from one database or data mart to another to keep their data secured, and the tool that is used to move across, making those transformations, logic changes, applying business rules to make the data, keep the data integrity from as they get from source and landing to the target. So that's kind of big picture I'm saying from a 10,000 feet.
Yeah, yeah, very nice. So Vinoda, what do you understand if would like to venture a guess? What do you understand by data warehousing? Uh,
Um, like you said, my understanding is like for a particular business, if there are like different databases and for different kind of business, what they want all the data to be saved in one single platform, so they can get the data from different databases, right? So the basic idea is to extract and have the data transformed to be aligned in line with the target database. So that's a basic ETL node, and that is the basic idea I have. I may be wrong, so.
Yeah, yeah. I think you both are quite, uh, close to the answer. So I will also try to, put in my views on this. So it's called data warehousing, right? So why do they use the word warehousing is what we will try to understand. So let us say that, I have a house and I have a lot of things in my house. Now there is going to be some stuff that I am not going to need to use. Okay, so what I'm going to do is that I'm going to move that into, let us say, a storage place somewhere inside my house, let us say my basement, right? Why? Because it is something that I'm not going to require on a regular basis. Okay, so think of data warehousing at a very basic level as a place where you want to keep your historic data. So let us say that I go to a store, let us say Walmart, and I buy something. Now that transaction that we did, and that what is known as point of sale system, that transaction is going to go into the billing system of Walmart. Okay, but that data is going to remain there for only 30 to 60 days. After that, what will happen is that the source system will purge that data out, because it doesn't, source systems generally don't have capacity to keep data beyond 60 to 90 days, especially for very, very large volumes. Now if the data gets purged, let us say, I made a sale, let us say, and after 90 days, this data gets purged. If somebody wants to know what happened before 90 days, they cannot find that out. Right? Why? Because the source system has already deleted all that data. So at a very basic level, a data warehouse is a place where you would save data that you will delete in your source system. Am I clear so far?
Yes.
Yeah.
Am I making sense?
Yes. So
Okay.
it's after 90 days, right? I mean,
Pardon me?
you said before 90 days. So you mean to say after 90 days, the data won't be there, it's purged.
Yeah, it will. So what happens is that as the volume of data increases in the source system, the system slows down, because the
Right.
system is not designed to keep large amounts of data. So they have all source systems have a purge process, wherein at some point in time what will happen is that the system will delete old data. So Walmart has a 90-day return period. So once that return period is over, they won't have that data in the source system. They will purge that data in the source system. So what they want to do before they purge this is that they want to save it somewhere for historical analysis. So at a very basic level, data warehouse is a place where they would actually save data which is now not going to be available in the source system. So maybe 2 years down the line, if somebody wanted to know what sales of laptops were at Walmart, they cannot go into the source system and find out, but that data is going to be there in the warehouse. So they would be able to go into the warehouse and find out what items sold 2 years ago, or 12 months ago. So all that analysis can be done over there. So at a very basic level, data warehouse is a place where you would save data that you would not have in the source system after X amount of time. That's one thing. The second thing why data warehouses are used, as you both rightly said, is for data integration. And this happens particularly when companies get purchased. So let us say that company A buys company B. Now company A has a different system and company B has a different system. And what you basically need is a consolidated reporting from system A plus system B. But since system A and system B are different, you cannot really do that. So now what you have to do is that you have to bring data from system A into a data warehouse, and you have to bring data from system B into a data warehouse, and this data warehouse now gives you a single view of the data. Am I making sense here?
Yes, yes.
Yeah. So data warehousing is number one, storing of,
Absolutely.
pardon me? Yeah, so data warehousing is saving of old data that will get purged in the data warehouse. And number two, it is about data integration, especially let us say, as I said, one company buys another company, you want a single view of the data because you cannot integrate source systems. Therefore, you integrate the data at the warehouse level and it gives you a single view. The third reason why we do data warehousing is in order to apply what is known as algorithms for data discovery. So what happens is that large companies, what they want to do is that they want to apply data algorithms to try and understand if there are any trends in their data. So what these trends do is that it helps them understand how sales are proceeding. So many times when you go online, you would have seen, what is known as requirements on dice for data scientists and all that. So what these people do, basically data scientists do, is that they are responsible for, writing algorithms that will, this historical data, which, generally companies will keep for 10, 12, 15 years. They will write algorithms which will run through the data and try to find out if, what is known as, if there are any trends or any specific kind of behavior which they can notice. So let me give you an example. So what Walmart, let us say Walmart is doing analysis and they realize that, there is a particular shift, on a particular day in a particular year, which because of some, what is known as holiday or festival, the amount of sale is really low. So let us say on 1st August, of every year, the sale is always very, very low. So if they are able to find from the last 12 years that this is always the case, what they can do is that they can reduce staffing at their, what is known as, at their stores on 1st August to a level which is optimum to the sale, so that they don't have to spend for wages on that day. So what I'm showing you here is an example of by how, analyzing the what is known as sale pattern, what we have really done is that we have actually, managed to cut our payroll costs, because most of these workers, they work hourly, and by reducing staffing at my store, what I have really done is that I have reduced my expense for that day unnecessarily. So this is just a very simple example of how historical analysis, help help companies reduce costs and all those things. Also there are trends of what items sell what time of the year. So clearly there are weather related items like coats and jackets and all that, but what having data over year will do is that it will tell us when the spike in sale comes, when it stops, and it helps companies make good inventory decisions, which at the end of the day help them save money. There are also a lot of other several examples like fraud analysis and all that, which a lot of companies do. That so maybe some other time I can go ahead and tell. So I will just go. As you see here, this is basically the data warehouse architecture, and what we are seeing here basically on the left side are the source systems. And by the source systems, what I meant is like something like a Walmart point of sale system, where data will actually come from the source systems and it will go into the ETL layer. Now, as you can also see that there is external data over here. A lot of companies, what they do is that they buy data from third-party companies, mainly in order to help them what is known as, do marketing kind of thing. So let us say that, I'm trying to sell something and I want to, send emails across to what is known as, a bunch of folks. So I can go out and buy these emails from a third-party company, and I could actually use that data in my ETL process, if I was doing an e-commerce kind of thing. So in the middle, what you see here is the ETL layer, and the ETL layer is the layer where we do all the where 90% of the effort is put, wherein you would do the cleaning process, making sure that your business rules are applied, and you may want to remove duplicate records, or if you are getting records that are coming from the same family, then you can do what is known as householding. And finally what you would do is that you would load them into the data warehouse. So as you can see on the source system side, now you could have had multiple source systems, but they would all actually go into the same enterprise data warehouse, providing a single view of the data. So, some of the ETL tools are actually listed below, like Informatica, and then there is Oracle Warehouse Builder. A lot of people use SQL Server, SSIS, and SQL scripts, and so on and so forth. In order to do ETL and load data into the enterprise data warehouse. So before I move ahead, Vishwa, any questions?
No, Sujit.
Vinod, any questions for me, please?
No, nothing from my end.
Okay, excellent. So now let's focus our attention on the data and metadata repository layer. Okay, now what you see here on the screen is basically you can see 3 data marts and 1 ODS. And I will try and explain what a data mart is and how it is different from an enterprise data warehouse. So what an enterprise data warehouse is that it basically contains data from all the what is known as it contains data from all the different systems of the company. So I may have finance, I may have sales, I may have human resources. These are different subject areas, and my enterprise warehouse will contain data for all these subject areas. But on a data mart level, what happens is that each data mart is specific for a given subject area. That means the data mart of the first data mart could be for finance, the second data mart could be for sales, and the third data mart could be for human resources. So in data marts, what happens is that you don't mix what is known as data of different subject areas. That means each data mart represents a particular subject area. Whereas in an enterprise data warehouse, what happens is that you will keep data across all the subject areas, as we just discussed: finance, sales, fraud, everything. So now let's try and understand what ODS is. So ODS, which stands for Operational Data Store, is generally a place where you would store data, and you would report off stuff that you cannot report from the enterprise data warehouse or the data mart. Okay, so let's try and understand what this means. So let us say that I have what is known as a transactional system. I go to Walmart and I buy, let us say, a pen. And when I buy a pen, what happens is that the source system on your left, on the first flow, basically has a record out there which indicates that there has been a sale. Now, if I try to locate that record in the enterprise data warehouse or in the data mart, I will not see it there. And the reason I will not see it there is because warehouses and marts, they follow the batch process. That means if I made a purchase today at 5 o'clock in the evening at Walmart, what will happen is that post midnight, all this data will be extracted from the source system and loaded into the warehouse. So now the question is that if I want to know what sales happened in the last 1 hour, what can I do? That is the question. So what I can do is that I can either go to the source system. Okay, I can either go to the source system to get the data, or I can create something known as the ODS, okay, which will get refreshed with sales data from the source system at regular intervals, like every 5 minutes, so that I can query the ODS and find out what sales are happening in the source system. Now the common question that I get is that, okay, so why create an ODS? Why not simply go into the source system and select it? So the primary reason for going to the ODS is because you don't want hundreds of reports running against the source system. It slows down the source system and it affects operational performance. So by putting in some software which will at every 5-minute interval refresh data from the source system, which in this case is the Walmart sales system, into the ODS, what it does is that it basically lets, let us say, all the users come to the ODS and prevent putting what is known as excessive load on the source system. So ODS, which is also known as the operational data store, is ultimately a place where you want to report data for that given day when the data has not yet made it to the warehouse or into the data mart. And the way that they normally the mechanism to refresh the source system and ODS, there are several mechanisms, but one commonly used mechanism is to use what is known as change data capture software. And this change data capture software basically refreshes the ODS regularly from the source system. So that is the primary role of the ODS, providing reporting for data that has not yet made it into the enterprise data warehouse or data mart. Any questions at this point?
Yeah, I have two questions, Sujit.
Yeah.
Can you hear me?
Yeah, I can hear you. Can you hear me?
So one question regarding data mart. So let's say like over a period of time, like 15, 20 years.
Yeah.
So if there are multiple subject areas, so we are saying like data mart is created purely for one particular subject area.
That is
So
right.
over a period of 20 years, do you think like the company would keep creating multiple data mart? Like they'll be like huge.
That is right. So data warehouse by itself is huge. Okay, but so yes, so see, one data mart for one subject area. So if I start a new line of business, or I have a new what is known as area that I need to work on, then in that case a new data mart will be created. Now what I'm trying to tell you is that the data mart does not necessarily have to hold all 20 years of data. The data warehouse will hold that. So when I get let us say I make a transaction today at Walmart and data flows into the enterprise data warehouse. What is going to happen is that the enterprise data warehouse is going to retain that information, let us say, for 15 years. Okay, but when
Okay.
data goes from the enterprise data warehouse into the sales data mart, I don't necessarily have to pull data for all 15 years. I could just pull it for the last 1 year.
Okay.
Now what happens is that after 1 year is over, I can drop the data from the data mart,
Okay.
whereas
Okay.
the data will continue to reside in the enterprise data warehouse.
Okay. So basically the data is actually going from the enterprise to data mart.
That is right. It is going from the enterprise data warehouse, which will always retain all history, to the enterprise data mart, which will basically be a subset of the enterprise data warehouse. And the other thing is that between the enterprise data warehouse and the data mart, we apply a lot of business logic that the business wants. so that the reports that run on the right side, you can see the presentation layer. The reports that run on the data mart can present that data to the business. So think of it this way, that I bought a pen. That pen went through the ETL layer into the data warehouse. Okay, now what
Okay.
happens is that that data is now pulled into the sales data mart. Now what business says is that there is a formula that you can apply to that sale, which will say my profitability dollar. So I bought this pen for $10, and you will apply a logic on that data as it enters the sales data mart, which will say is that okay, my profit margin is $1 on this. So that logic or all that calculation that business wants, we apply on the data as it flows from the enterprise data warehouse into the data mart, and then we report off that in the presentation layer.
Okay. Sorry, I didn't want to interrupt
No,
asking
no, no.
questions.
Go ahead. I like interaction. Interaction.
Yeah, so basically, this just throws up one more question. So basically, the reports that are being pulled are actually talking to data mart, but not to the enterprise data warehouse, correct?
So what happens is that in a pure world, in a pure world, that is what should happen. But as we know, what happens is that it costs money to create data marts.
Correct.
So a lot of companies, what they do is that it's all about a question of, do we want to spend money building a data mart? And then a lot of times what happens is that it creates a hodgepodge kind of thing where it goes half against a data mart, half against a warehouse, and all those kind of messy things happen. So in a pure world, or in a pure if you follow pure data warehousing architecture, yes, all reporting should happen only in data mart, but in the real world it happens all over the place.
Okay. So one last question,
No, no, go ahead.
sorry.
Yeah.
So the ODS, so ODS, how, so is that, does a batch file goes and update on a daily to enterprise, or does the data which is refreshed in ODS is feeding the enterprise data warehouse?
No, in this particular architecture that I'm showing you, that ODS is not feeding either the warehouse or the data mart. ODS
Okay.
is standalone. Okay. In this particular
Okay.
case, the ODS is standalone, wherein data is getting refreshed from the source system into the ODS for only, and the only reason why this is happening is to enable what is known as same day reporting. So let me give you a classic example of back to school sales. Okay, now what happens
Okay.
is that in most retailers, back to school sale is very important, where they want to know how the sale is proceeding within a given day. So they want to see how sales are proceeding every hour, so as to decide whether they want to lower the prices, increase the prices, offer discounts and all that. So
So
they cannot, yeah, go ahead. Yes, sir.
yeah, that's a good, yeah, I think that's a beautiful example.
Yeah,
Please keep going.
yeah. So they cannot really wait for the next day because the opportunity is already gone. So what they have to do is that if they want to know the sale, they have to either go to the source system, or they have to have some place where the source system data is going to show up. And that place where the source system data is going to show up is actually the ODS. Okay, so
Okay.
what they do is that they have software that actually refreshes the source system. It reads data from the source system and refreshes the ODS. And you can actually see sales data from the source system in the ODS at generally a 5-minute interval. So, and the reason that they create ODS is because they don't want people to go against the source system. Suddenly you have 5,000 stores, you have 5,000 managers, coming against the source system. The system will slow down substantially. They don't want to do that. So for that reason, the ODS.
Thank you very much, Sujit.
Yeah. Vinoda, any questions for me?
Yes, actually, you answered most of them. But regarding the ODS, when you say it's get refreshed every 5 minutes, like job runs to get
No,
the
no,
data from the
there is no job. So generally there is certain software in the market.
uh-huh.
One of them is the Oracle Change Data Capture software,
Okay.
which basically what happens is that it reads the change log from the source system,
Okay.
and using that change log it automatically refreshes the ODS. So generally the table structures in the ODS will be exactly similar to what is there in the source system. And what it is simply doing is that it is reading the logs from the source system and is refreshing the ODS.
Okay, and it will have data for the 12 hours that you said, like after midnight anyway, ETL will load all the data to the warehouse, right?
That is
So
right.
would it, okay,
That is right. So we can set, so whoever is managing the ODS can set what is known as the how quickly they want data to be purged in the ODS. Generally, they would keep it equivalent to the source system. Generally, they would keep the ODS data retention period equivalent to the source system. So if somebody wanted to go against the source system and do a reporting, they can come to the ODS and do exactly that.
so would it be like a mirror of the source system,
In most,
but for just for 12 hours
yeah, yeah,
or
yeah,
24
yeah. In
hours?
most cases, yes, it is almost like a production mirror, wherein you can what is known as see what's happening. Yeah, it's almost like a production mirror. That's true. The thing about the ODS is that you can do more. You can create some schemas where you can do some in same day reporting. So let us say that you could create a separate schema in ODS which doesn't exist in the source system, like a view or something, which offers you like a view of what is happening for that day. So you can do more stuff in the ODS. So though it is a production mirror, you can enhance it to add some more capabilities to help you for same day reporting.
Sure. Also, one last question. I'm sorry.
Sure, sure.
For ODS, will it have data from the different line of business as well, like sales as well as
So,
if
so,
they want to
generally,
have it?
so generally, the way I have seen in most places is that one ODS represents one source system. So, if it is representing sales, it will be sales. If it is
But
representing finance, then it will be finance. If it is representing human resources, it will represent human resources. Generally, they will create ODS for only those areas where it is critical for them. Uh, so generally, they will not create an ODS for human resources because, there is nothing related to same day reporting that they need to do. So,
okay,
they can wait for one day for the data to come into the warehouse and if they want to do any, reporting. But for something like sales, which is directly affecting their money, they would create what is known as an ODS, which is like a hot area where they can see
okay.
the data coming in and they can make decisions based on what they are seeing.
So one last question. When
Sure,
you
sure.
say, we have say, let's see, we have sales for on the ODS. What if I want to have the inventory too? Because inventory also changes. Like the same example that you say for the back to school.
Right.
If they want to take the inventory as well, can they have two ODS in
Yes,
that
they
case?
can definitely have. They can have as many ODSs as they want, as long as it makes business sense for them to do so. So generally with inventory, what happens is that there are APIs that, especially APIs on e-commerce thing that I've seen is that which actually goes and fetches the current inventory level. So I haven't seen any inventory based ODSs, but yes, there is nothing that really stops anybody from doing that. Inventory based ODSs, they can definitely do it if it makes business sense for them to do that.
Sure. Thank you.
Okay, so finally it is the presentation layer, which is the presentation layer where we do all the reporting. As you can also see here, a very important thing is the data mining tools, which I was talking about data scientists doing what is known as data scientists doing what is known as all their data mining, finding trends and all those things. So this is a topic that we just spoke about, OLTP, which is the operational system, and the other is the data warehouse. So the operational system basically handles millions of transactions per day, but the data warehouse is like a batch. It is like a batch. So what happens is that there is one batch at the end of the day. So and the operational system, it does not keep history beyond generally 90 days, but the data warehouse, the primary goal of the data warehouse is to keep history. and OLTP, which is the operational system, it gets loaded as the business operates. If you go buy a phone at Walmart, data is going to get loaded in the operational system, but in the warehouse, it's batch job, it gets loaded in the night. Any questions at this point? Okay, so here what we discussed was the difference between the operational system, which is the source system on the left, and the data warehouse on the right. So over here, what we are seeing is that it is basically at a high level, what they're trying to explain is that the model type between the source system and what is known as the target system are different. The source system basically has what is known as an ER model concept. Okay, and the warehouse has what is known as a dimensional model concept. So let me try and explain at a high level why the data model at the source system needs to be different from the model at the warehouse. So the primary reason for this is because the source system's goal is to take data in, which is, you buy something, you scan something, it creates a row and it goes in. It wants, whereas in a warehouse system, the goal is to get the data out. That means you want to report out of it primarily. So for that reason, what happens in an ER model, which is nothing else but an operational system model, is that it is designed to, eliminate data redundancy and, have high transaction performance. Whereas in a dimensional model, what we have is that we encourage data redundancy in order to be able to get good query performance. So data redundancy means duplicate data, or same data being present in more than one place. So in an operational system, our goal is always to reduce that, and in a dimensional model, our goal is always to improve query performance. So even if we repeat the same information in more than one place, it doesn't matter all that much. I will tell you more about this as we move forward, but if you have any questions, I'll be glad to answer them now. Okay, so okay, let's move on. So what we are seeing here now is basically what is known as the fact and dimensions. So here what we are seeing basically, this is fact, dimension, star flake schema and snowflake schema. So let's try and understand this. So here we are talking about what is known as design of the data warehouse. What we are trying to talk about is the design of the warehouse. And what a fact table is basically is, it is a table which has all the transactions related to the business. So if let us say that I buy a pen, my sale information will go into a fact. Where will my sale go? It will go into a fact table. Okay, so what is a fact? The fact is the place where what is known as all the information of all my transactions are kept. So let us say that I have a sales fact, all my sale information will go there. If let us say, I have, a fact related to employees, and if I make a change in my address, what will happen is that if I had a fact that maintained HR data, then, that transaction or whatever I did on my source system would go into the HRMS fact. So what is a fact? A fact is nothing else but the place where all our transactions are retained. Okay, so a fact contains measures. Measures means there are things like dollar amounts which help us, figure out how the business is doing. So if let us say that I pay a bill for my internet service, that information of that bill is actually going to go into a fact. So what is a fact? A fact is are transactions that are related to the business that store measures which in most cases would mean dollar amounts. Am I making sense, or do you want me to give a different example? Vishwa?
I think it's good.
Vinoda?
I think it's good.
Good. I'm good too.
Okay. So let's try and okay, then in that case let's try and figure out what a dimension is. Okay, so let's try and understand what a dimension is. So a dimension is something that describes a fact record. So when I buy a pen, what is going in this pen has a product ID associated with it. Okay, so what is going to happen is that this product ID is going to go into the what is known as sales fact table. So when I look at a row in the fact table, when I see a product ID, by looking at that product ID, I will not be able to tell whether this was a pen or this is a phone or it is a mouse or what it is. So even though I have a fact table, that fact table has all my transactions, it has a product ID. What it is not able to tell me is that it is not able to describe that transaction to me, right? So I need something that will describe what this sale was. Was this a pen sale? Was it a mouse sale? Was it a laptop sale? And dimension is that part of the data warehouse which tells us what it tells us exactly what that product was. So let us say I have a product ID 100 in a sales fact table. What the dimension basically contains is that it contains description of what 100 means. So if I go to a dimension table, it will say product ID 100 and the description will say that it is a blue paper mate pen. So dimension basically they contain business attributes or attributes that are textual in nature, so that it describes what is happening in the fact. And when we do reporting, the reason why we need dimensions is because dimensions help explain to us what the numbers mean. So otherwise these numbers wouldn't make any sense without something explaining what these numbers mean. So if I wanted to know sales of all pens, basically what I would do is that I would pick all product IDs 100, and by looking at the dimension, because it says 100, I can join the fact to the dimension and then come to know that all hundreds are basically pens that I'm trying to sell. Any particular question here? Any question for me?
Yeah, I have a question.
Yeah, sure.
So I'm just throwing this an example. If I go to Walmart and I scan a product,
Yeah,
let's say I scan a pen,
yeah,
so it throws out like a product key, whatever the numbers are.
yeah.
So can I say that is a fact that goes into fact, that key,
Yes,
and then when it goes and stores in a warehouse, the warehouse has the dimensions, which is the description of that product key. Is it
that is
correct?
correct. So nothing stops that description from being present in the source also. It is possible that the description of that product is present in the source also, but the point is that once this row reaches what is known as the warehouse into the fact, something is required in the warehouse to describe that product ID. So as you
Okay.
said, let us say that you purchased a pen, it has product ID 100, and what happened is that this product ID 100, inside the source system there is already a table which says that this is product ID 100 is pen. Okay, now this row enters the fact table. Now when this row enters the fact table, what we want to do is that we want a dimension so that it contains information on what 100 actually means, which is nothing else but the what is known as the description that this is a paper mate pen. Vishwa, did I confuse you?
No. That makes absolute sense. Thanks. Yeah.
Okay. Vinoda?
I'm good.
Okay. So basically what is a dimension? A dimension is nothing else but something that describes a fact row. So let me give another example. See, I have Comcast. So when my transaction goes into the billing fact for Comcast, okay, it is going to have a product ID associated with it. So when somebody wants to know what product I am using, they have to go into the dimension to find out what that product is, because the dimension will tell that I have 25 Mbps XYZ, this thing. But how much I'm paying for that as a fee, which is a measure, is actually going to be inside what is known as the fact table. So I'll move to the next one. So the next thing that we're talking about is, this is actually the star schema and the snowflake schema is a little advanced concept, but I will give you a high level overview of this. So what happens is that, one second. Yeah, so what happens is that so I'll explain what a snowflake is first, and then we will come to a star. So what a snowflake is really is that it is something that is related to a hierarchy. Okay, so let us say that let me talk about a real world example that I had encountered. Okay, it's called DCPS. Okay, so D stands for distributor, C stands for customer, P stands for product, and S stands for site. Okay, no, you know what? Let me stick to the Walmart example. Let's talk about a hierarchy. So let us say I have a product, which is a pen. Okay, now if so, what happens is that a pen is a product, but it also belongs to a particular category, right? So pen is a product, but it could also belong to a particular category. So what is the category that pen belongs to? It belongs to the category of office supplies. So if I have a product ID 100, it belongs to which category? It belongs to a category of office supplies. And then there are a lot of other things that also belong to the category of office supplies. For example, there could be books, there could be crayons, there could be envelopes. All these have their own product IDs, but they all still belong to the category of office products. Okay, so what is office product really? Office product is the parent of the pen product. Yes or no? Any confusion here? Vishwa, Vinoda?
Yeah, no, I'm good.
Yeah, Vishwa, are you with me?
Yeah, I'm good. I'm good.
Yeah. So what's basically, so what category is basically the parent of category is basically the parent of the pen. So what is the pen, the paper, and all these kind of things? So essentially what is happening here is that we have a hierarchy. That means a product has a parent. Okay, now the parent is basically the category, and now above this category there could be another category which could say edible or non-edible. Okay, so what is that edible and non-edible mean? It basically means is that products that are not meant for human consumption, okay, they are non-edible. So things like tires, this, that, which, so let's talk about a tire. A tire can have a category that belongs to automotive products. Tire has a parent category which belongs to automotive products. So now so now automotive products and both the what is known as office products, they both will roll up to the same parent, which is non-edible items. So essentially what I'm trying to say here is that when you have a hierarchy like a tire, and it has a parent called automotive product, and then it has a parent called non-edible items, and you have a product like paper, a parent category like parent category called office products, and then a parent category again called non-edible products. What you're essentially forming is a hierarchy. And when you form a hierarchy, when you have a situation where there is a hierarchy, you need what is known as a snowflake schema, because you create what is known as a dimension table, and then you have to relate one dimension table to the other. Whereas in a star schema, what happens is that there is no hierarchy like the one that I explained here. There is no hierarchy. So dimensions without hierarchies belong to star schema, and dimensions with hierarchies belong to snowflake schema. So as you can see here, this is an example of the star schema. You have a central fact table. Okay, you have a central fact table and you have dimension tables on the side. So let us say, if you see, these dimension tables are only related to the fact and they are not related to any other dimension tables. So therefore, this is a star schema. Okay. So this is the example. This is sales, there is store, there is product, and there is period. Product and period are not related. Store and product are not related. Store and period are not related. Now look at this. This is an example of a snowflake. The store dimension is related to the district dimension, and the district dimension is related to the region dimension. So what is happening is that there is a relationship between store dimension and district dimension. So therefore, this is an example of a snowflake. See, over here you see the product is not related to anything else. So because the product is not related to anything else, therefore the relationship between product and sales is a star. Okay. Now let's go here. Now what they did, they further normalized the store dimension, created a district and a region table. So now the dimension is related to district and then district is related to region. That means dimensions are related to other dimensions, which makes it a snowflake. Yeah, Vinod, any questions for me?
No, Sujit.
Right.
Sujit,
Yeah.
I have a question.
Yeah,
So is this something like one to many, many to one kind of relation?
That is right. It is a one to many and many to one relationship. But the key thing here is that it is a relationship between dimensions. See, if you look at this PPT, which of the star schema, see, you're seeing a central sales fact, right? And you're seeing dimensions on the side. But if you look at the period and the product and the store, they are not related to each other in any way. So if you wanted sales, and if you wanted for a given product in a given store, okay, just look at this. You have a central sales table. So if you wanted sales for a given product in a given store, okay, what you would do is that you would join them all through the sales fact. You would need the sales fact in between to join them. But in the next slide, what you're seeing is that the store dimension, okay, which is related to the store fact, is now related to, the district dimension and then the region dimension, which in itself are other dimensions. So because dimensions are related to dimensions, and in order to join the store dimension with the district dimension, there is no need to go to the fact table. You can directly join the district ID with the district ID here, and then the region ID in the district dimension with the region ID in the region dimension. For that reason, it is called a snowflake schema. So basically we would use a snowflake whenever there is a hierarchy, like stores roll into districts and district roll into regions. Does that answer your question, Vishwa?
Yeah, Sujit.
Go ahead. If you have any other questions, I'll be glad to answer.
It should be good.
Okay. Okay, let's move on then. So we already spoke about this. This is data marts, which is logical subset of data from the warehouse, and then we spoke about the ODS, which is operational system, and primarily for the same day reporting you can use it. And OLAP and all these things are related to reporting, so that you can what is known as get best result from your reporting system. Reporting systems are also very important. and finally this piece. So yeah, so this is the reporting piece which actually happens after, you know, what is known as the data from the data mart is loaded. This is actually an advanced concept, you know, I won't talk about it now. And basically here you can see there are some, the important thing here is the drill down, drill up, slice and dice, cubes. Let me talk about these briefly, you know, because these are terms that you will always hear. So let me talk about cubes to begin with. So what happens is that, many times when you try to report data from a data warehouse or data mart, because of the extreme high volumes of data, what happens is that it is not possible to report quickly. So what people do is that they use a reporting tool like Cognos, and what they do is that they create what is known as a cube, which is a three-dimensional aggregation of data. Okay, and this three-dimensional aggregation of data, what happens because of that is that because the data is already present inside the cube, when people are trying to report off the cube, you know, you get sub-second responses from the cube. So let us say I have a sales fact, and I have store, and I have what is known as I have sales fact, I have store, and I have product. If let us say I pre-joined all this data and I put it inside a reporting tool, what would happen? Such a thing, if called a cube, would, you know, help me, you know, very quickly report from it. So cubes are nothing else but pre-aggregated data stored inside reporting tools like Cognos, you know, which reduce query execution to sub-second. So, you know, that is what cubes are. Any questions regarding cubes?
Can you create as many cubes as you want? It will not affect the performance when they query.
So generally you will have one cube to represent one area. So let us say you want to figure out sales. So you will have the sales fact, okay, the store dimension and the product dimension. You will join these three and you will create a cube out of it, and you will limit the data in that cube to, let us say, 1 year, you know, for our discussion's sake. Now as the cube becomes larger, yes, the performance will get affected, and as you have more cubes, it will not affect the performance of the other cubes. But if a given cube is very large, it will, you know, creating that cube will take time. So what is a cube? It's a pre-aggregation of data. So essentially what I'm doing, once my fact and once my dimensions are loaded, I will join the fact and the dimensions and, you know, create a cube. So as more data goes into the cube, the time required to refresh a cube grows. But, you know, once the cube is created, the reporting won't take any time. It will still be sub-second.
Sujit,
Yeah.
is this cube similar to the ODS that we talked about, like a refresh data and have it in
No,
a
no, no,
separate?
it is not. It is not similar. Actually, I don't have a Cognos report to show you here. Otherwise, it would have made sense. See, what the ODS does is that it brings in it brings in data every 5 minutes for me to be able to, you know, do immediate reporting. But
Mm-hmm.
Cube actually runs only at the end of the day, once all the data loads are complete into the data warehouse and the data marts. So you create cubes in Cognos out of data marts and data warehouses. So what is a cube? It is nothing else but pre-aggregating data that is present in the data warehouse for reporting. So instead of my report going into the fact and going into the dimension and creating a report which will take a lot of time, what I am doing is that I am getting all the data for a given time period and creating a cube inside Cognos. So when somebody is trying to report, it doesn't have to actually go into the data warehouse. It will report directly off the cube.
Is it kind of a cache memory wherein
Yeah, you can
you?
say that it is a kind of a pre-aggregation happening inside the report for quick performance. So think of this way. You are the CEO of a company and you want to know what sales happened yesterday. You click the report and it takes 25 minutes for it to come back. because it has to run on the fact and run on the dimension. So such people at the top have no patience. So what they are doing is that they are basically taking the data from the fact, taking the data from the dimension, joining everything up and putting it inside something known as a cube and putting it inside the reporting tool. Now this process takes a lot of time, right? But once the data is there inside the cube, once I start trying to use the reports, because the data is already inside the cube, my reports will run really fast, as against if it had to actually go into the fact and into the dimensions and get all this data. You know that?
Yeah, I got it now. Thanks.
Yeah. So what is cube? Cube is nothing else but a we are pre-aggregating data from the facts and the dimensions and storing it into the reporting tool to what is known as enable what is known as quick reporting for higher level executives. And the drill down, drill up, slice and dice are all related to the same thing. Now let us say that I am seeing sales by state. Okay, I'm seeing sales by state. So if I'm seeing, let us say there are 50 states in the United States and I have a report that shows me sale for every state yesterday. Now there is a given state which is showing very poor sales. So now I want to investigate what the reason for this poor sale is. And if I want to do that, what I have to do is that I have to drill down into the report. So what I will do is that I will double click that state. So let us say I double click, let us say Michigan. Okay. So if I double click Michigan.
Sujit, I don't know if you are sharing a different screen. It shows others.
Yeah, you can see just below cube there is drill down and drill up.
Oh, got it.
Yeah. So I'm still on this. You can see the drill down and drill up. We're talking about the drill down and drill up. Yeah. So let us say that sales in Michigan yesterday were really poor. Okay, so when I double click on Michigan, what it will do is that it will show me all sales in Michigan broken by what is known as the county. So what I have done, I have drilled down into Michigan and I have gone, now it is displaying data to me as sales by county. Now I scan all these counties and I see that in one particular county the sale is poor. So what I will do, I will double click that county, and when I double click that county, what it will do is that it will show me all the stores in that county. So what I'm doing here is that I'm actually drilling down into the report to try and find what is happening where. And then I could actually find that this is the poor performing store, and then I double click that store and I will go into that, and then I may realize that what, this store was closed because of XYZ problem. So what is drill down? Basically the drill down is the process of wherein I have a report which is based off a cube, and basically it allows me to quickly go down into more detail level, and thus allowing me to identify what problems there could have been. Drill up is just the opposite of drill down, wherein you're coming from a lower level granularity into a higher level granularity. Any questions on this,
No questions.
Vinoda?
No questions. No
Okay,
questions from
so
me.
finally the last topic on this page that I will talk about is the slowly changing dimensions, and then we will move on to Informatica quickly. What are slowly changing dimensions? So we just briefly spoke about dimensions, in which we spoke about what is known as a product being stored, and the product basically has a description, and that description basically explains what that product is. So it is quite possible that these dimension descriptions could change. So let us take the example of a customer dimension. So there is a company called ABC. Okay, and that company ABC has a what is known as a company ID of, let us say, 101. Now if this company name changes from ABC to XYZ, what is going to happen in a slowly changing dimension is that we don't direct what happens is that we actually leave the old row with the old name ABC as is, and we will insert a new row with the same company ID, okay, which is what is known as 101, and with the new name and with a flag which will tell us that this is the latest what is known as this is the latest row. So what a slowly changing dimension basically is that changes happening to descriptions, and we actually capture that information so that we can know what changes happen to a given product or a given employee over a period of time. Let me see if I yeah. So let's look for a example. Right. So let us say that we have this, you can see this product. Can you see my screen? The product, can you see the product over here on the left?
Yes.
Yeah. So I have a product code, which let us say is pen, and the description says, paper made pen, and the color is actually blue. Okay. And the size is, let us say, 10. Now what happened is that the color of this pen, later changed, and from blue it turned black. So what will happen in this dimension is that we will add a new row. Okay, we will add a new row where what we will do is that the color will now be black. Okay, and this new row that was inserted, it will have a flag which will say that this is the latest row, to indicate that this is the latest row in this dimension. So that ways what we are doing is that in the product table we are retaining history, and we are showing how things have changed on that product over a period of time. So this is so the concept of slowly changing dimension is very important, because it helps us to do historical analysis for that reason. So this was the last topic on the data warehousing. Any questions for me?
No.
Okay, so what I'll do is that I will quickly what is known as go into Informatica, and I will show you the tool, and is my screen visible?
Yes. Yes.
Yes, yes.
Yeah. So so we spoke about ETL and all that, and basically what you're seeing here is the Informatica Power Center, which is the tool that is primarily used for what is known as the ETL process. And basically this tool, which is called the Power Center, has a couple of components. What we are seeing right now is the designer. Okay, then we have something what is known as the workflow manager. I will explain what that is. Then we have what is known as the monitor, and finally the repository manager. So the designer is the place where a developer or an architect spends 90% of his time. This is the place where all the Informatica mappings are created, and all the logic or all the code required to do ETL, reading from the source and writing to the target, all that logic is written inside this designer. The next one that we have here is the tool, which is is called as the workflow manager. Whatever code that we have actually created inside what is known as the designer, we can actually execute that inside the what is known as the workflow manager. Okay, so what is workflow manager? Workflow manager is basically the tool that helps us run code that we have built inside the designer. Okay, so the next one is the monitor. The monitor is the place where we monitor jobs that are running. So let us say that I have what is known as I created a job inside this green designer, and I created a job inside this orange workflow manager. When I run the job, what will happen is that I will be able to see it here, and I will be able to see all details of data being loaded and so on and so forth. Okay, all that information is going to be here. How many rows were there, and this and all that information is actually going to be here. So let's quickly, I'll just quickly create a, mapping to show how Informatica works. And right. So we have a concept of folders here, wherein what happens is that there are folders in which you work. As a developer, typically you would work inside the development folder, right? So when you connect, what will happen is that you will be given a user ID password, and you basically need to use that user ID password, and you should connect to Informatica. Once you connect into Informatica, there will be a development folder where you can actually what is known as you can actually go and build your mappings. Okay, so what I'm going to do here is that I'm going to show you a mapping that already exists. And so here this is like the hello world of Java, which basically what we are saying is that we have an employees table here, and we have a copy employees table here, and we want to read data from the employees table and load it into the copy employees table. Okay, so what I'm going to do is that I'm going to select data from here. As you can see, my employees table is populated. I'm going to select data from here. Okay, my copy emp is also populated, so I'm going to truncate the data. Okay, let me see, I have copy emp. Now my copy emp is empty. So what is my goal right now? My goal right now is to read data from emp and load it into copy emp. This is like a very simple example, but in real world what will be happening, you will be reading data from different source systems, or different from multiple source systems, and writing into the warehouse. What do we see here? Here we see that we have what is known as metadata representation of the source. That means this piece here represents the employees table here. This piece here represents employee table in Oracle. This is an intermediate step that I need to add. And this copy emp is the target. As you can see, a target definition that represents what is known as the target, or this table into which we are planning to write data. Okay, so very simple mapping in which we are reading data from the employees table and writing it into the copy emp table. So I'm going to go into my workflow, and what I'm going to do here is that I'm going to open this workflow. As you can see, and double clicking this contains the name of the mapping M001 employees to copy emp. You can see here it's the same name here, which means that this workflow, which is nothing else but a job that is designed. I will show you how the job is created, but I'm giving a high level overview. This job is linked to this mapping, and when I run this job, what will happen is that this mapping logic will get executed. So I'm going to run workflow. I'm going to do start workflow. Workflow has started, and I'm going to open. Okay, so if you look at the timing here, this just ran right now. What I'm going to do is that I'm going to just show you how this I'm going to truncate this. Okay, and what I'm going to do is that I'm going to run this again. This thing is running too quickly. What I'm trying to do is that I'm trying to show you the execution process. Okay. Okay, so let's see, is there data inside this? There is no data inside this. I'm actually going to run this workflow. Okay, so this stuff is running very quickly, so we are not able to see it running. But if we go to this table now, copy MP, which was empty a couple of minutes ago, you will see that now there is data here. Okay, so what actually happened is that this mapping that I have written to copy data from employees to copy EMP, okay, I executed this with the help of this orange thing, which is nothing else but the workflow manager, and the date and the information about how many rows were inserted is listed here. And if I right click and I look at this, here it is the log, and this log is basically nothing else. It basically contains information on what happened, if there are any errors, and all those kind of things are there. So what we've seen here is basically how typically we would create an Informatica mapping in Designer, which is the green thing, create a workflow which is nothing else but an object which helps us running this mapping, and then finally we could see the statistics of what ran over here inside the monitor. It will tell you how many rows were inserted, if there were any rejected rows, and how much time it took. In this case it is showing as 0.2 seconds, which is very small, because of which we were not able to see it actually running. So any questions at this point before I start the next piece?
No, Sujit.
Vinoda?
No, Sujit.
Okay, so what we will do now, what I will do now is that I will, quickly show some of the features of Informatica and how we create sources and targets. And so this is what is known as the source analyzer. And the source analyzer is the place where we create, this source which is associated with what is known as, what is known as the table from which we want to read data. So let us say that I want to read data from the departments table. Okay, and if I want to read data from the departments table, what I can do is that I can actually import data from here. So in the source analyzer, I would go to source, I would do import from database, and sorry, I need to put in the password. Okay, so what I'm trying to do here is that I'm in the source analyzer in the Power Center Designer, and over here what I'm doing is that I have all these bunch of tables, and what I'm going to do is that I'm going to import what is known as these tables. I have to decide whether I want to import them as source or target. So in this particular case, what I'm doing is that I am importing locations. So essentially what happened is over here is that I imported the table locations, and this is basically the metadata inside Informatica, which represents locations in what is known as, it represents location inside the same structure, everything as is present in the Oracle database. Now I did the source thing. Now the next thing I have to do is that I have to import what is known as a target. So what I'm going to do is that I'm going to create a table called copy dpt. Okay, so I created a table called copy DEPT1, and what I'm going to do is that now I need, like how inside this mapping I have a target, I need to create something over here that represents a target. So again I will go here, I need to import the target. Okay, I will go here, I'll go to tables and I will select copy DEPT1. Now once I do that, what will happen is that copy DEPT1 will show up here. So what I have done really is that the first step in creating any code to read data from a particular place and write it to something else is basically to create the source definition and the target definition from where you want to read and write data. Okay, and that is what we have done. Now at this point, since we are completed, when we do this import, what will happen is that the tables will show up on the left side in your browser window to indicate that they are there, and then you should save them. I already saved them previously, but you should save them, what is known as, to be able to to make sure that you don't lose them. So step 1, create the sources. Step 2, create the target. And the third step that we do here is that we create a mapping. I'm going to call this M002 underscore DEPT to what is known as no, we are reading locations, right? What did we create? Sorry, departments. Did I import locations or did I import departments? I did locations here, but I did department 0. That's not right. So I think that was not good. I'm going to LOC and I'm going to do locations here. Okay, so I'm going to do locations here, and what do I need to do next? I need to make sure that I have locations target available in order to what is known as import, in order to load data into copy locations. So I go to this thing and I'm going to see if I can find copy locations. Okay, I have copy LOC. I import it, I save it. So what do I have? On the source side I have locations, on the target side I have copy location, and now what I'm going to do is that I'm going to create a mapping M underscore 001 underscore LOC to copy underscore LOC. Okay, generally the name of the mapping should be descriptive so that we can better understand what it is. So now my workspace where I can write the code is present. Now I click locations and I bring it in. Now every time we pull a source, automatically a source qualifier will come. The source qualifier represents the point. The source represents the metadata that represents the source on the database, and source qualifier is the point at which what is known as data is loaded, data enters Informatica. Over here what I have is that I have what is known as the copy EMP, which is the target into which I'm going to write data. Now if you see here, there is what is known as transformations. You can see I do create. You can see there are a bunch of transformations. These transformations are nothing else but stuff that give you the ability to write code in Informatica. So if you wanted to update a table, you would use update strategy. If you wanted to write an IIF logic, you would use expression. If you wanted to call a stored procedure, then you would use a stored procedure transform. If you wanted to basically get sequence number, you would use sequence generator. If you wanted to what is known as do group by, you would use an aggregator. If you wanted to write a where clause, you would use a filter. You would do a lookup if you wanted to get related values, and so on and so forth. There are a series like joiner for joins, router for routing data, normalizer for normalizing, ranking. So these what is known as transformations are basically what an Informatica developer or a data warehouse developer would use regularly, and use it to actually what is known as work on a daily basis to achieve what, like read data from the source system and write to the target. So for example, if somebody wanted aggregated sales for the entire day, then to load it into an aggregate fact, they would use an aggregator in Informatica, read data from the source, group it, and load only all sales for pens in a given day, instead of inserting every row of every pen sale that exists. So these are all the stuff that we can use. We will start off by using expression. XP underscore. So I have what is known as an expression. In this particular case, what is known as, I'm going to just do a pass through. I'm going to connect from here to here. Now, so let me give you an example of what is known as how we use this expression. Okay, so let us say let us say that in this copy emp table I have what is known as, uh, let me do something else. So let us say that I'm loading city to the city table, and I've been told that there are spaces inside the city table. Okay, so what I am required to do is that I'm required to trim data. So what I'm doing is that I'm creating a column. I'm creating a column called O underscore city, and what I'm going to do is that I'm going to do a trim here, and I'm going to go to ports, and I'm going to take city, and I'm going to apply it here. Okay. Okay, so here, so let us say that we had a business requirement that city data, it contains spaces, and that is why you were required to left trim and right trim this. So what I basically did inside the expression is that inside the expression I applied business logic. Okay, I applied business logic, which actually helps me to what is known as, okay, invalid. Okay, so let us say that the business gives you a requirement that you're reading data from the locations table, and you're writing it into the copy locations table, and what they require you to do is that they want you to trim the data in the city table before loading it into the city target. So here what the expression is basically the place where you would typically apply row level what is known as logic inside a mapping. So in this particular case, this ltrim rtrim is applied, into this thing. So like ltrim rtrim, what happens is that there are a lot of functions that are available in Informatica, and you can apply all these functions on, you can apply all these functions on data that is coming in. You can also create your own functions called UDF, which is called user defined functions, if you want to create a functionality that does not exist here. So the expression is a very important what is known as piece which we use in Informatica mappings. And like expression, there are several others which we will see when we do the course. So what I'm going to do now is that I'm going to go here. So what have I done here? Here I have created a mapping where I'm reading data from locations, going, I put in a logic to trim the data, and I'm loading it into the locations table. My next task is to basically create a workflow, and I'm going to give this a name. So the way we generally name it is that we basically go home and then we remove this M and then we do WF, and then over here we will locate our what is known as this is our mapping. We will click next, we will do finish. So what we have here is that we have our workflow, and over here we have to actually, this automatically got it, but this is basically the connection that helps it to read data. You can see here I have a connection. This is the connection that helps Informatica connect to this database. I already had it in, so that is why I didn't have to give it again. But when you are creating for the first time, inside this workflow, you will actually need to what is known as provide the net information. Now let me see what I have here. I'm going to do select star from locations. Okay, I have data here. I'm going to do select star from copy LOC. There is nothing here. Okay, now what I will do is that I will go to workflow. I will do start workflow. Okay, this already succeeded. Let us see what information it gives us. So it says that it read 23 rows. It applied 23 rows. It did not reject any rows. Its throughput was 3542 rows per second. There were no errors were encountered, and it basically gives the start time and the end time. This is useful when you want metrics on how much time each particular job is taking and all that. So what we have actually seen here is that this is how typically an Informatica developer would go about building. This is actually a very simple example. When you work real time, the mappings can be extremely complex, and they can have a lot of challenges, and all those challenges that exist are going to be there. It is not going to be as simple as this. Any questions for me, Vishwa?
No questions, Sujit.
Okay. So we are at the end of this session. So if do you have any questions for me?
No, no
So
questions,
yeah,
sir.
so what I will, okay, so then let's wind up now. I will be sending out a survey questionnaire, and when you get a chance, do fill it up, and send me your feedback on what you liked and did not like about the session, and it'll ask you some questions, and you're free to give your own comments. If you will be able to provide that feedback, it'll help me improve my demo sessions in future. And sorry for going overboard. I have 45 minutes above, and sorry for that.
No problem.
Okay then, everyone.
Thank,
Yeah, thank you.
thank you.
Yeah, thank you.
Thank you very
Yeah, thank you, Vishwa. Thank you, everybody. Okay, take care. Bye.